5.5 has really two topics. It starts with negative exponents. We've had the negative exponent rule, but we haven't used it for anything. And it goes on, and the only other topic we cover in there is scientific notation, which is usually applicable in a science class, but we do go over it in here. So we will start, and I will review the negative exponent rule. All right, the negative exponent rule says if you have some base x, it could be any base, you raise it to a negative power. That in no way affects the sign of the answer. What it affects is the position of base x. It becomes 1 over x to the positive a. And at first that seems very strange, that an exponent tells you to move this base to the denominator of a fraction, and then the exponent becomes positive. Negative exponents are inappropriate to be left in answers. They're bad form. A negative exponent in my everyday language says, move me. A negative exponent says, move this base across the fraction line, and the base will be raised to then a positive power. Let me see if I can convince you of that. What if I had x to the second over x to the fifth? What does the quotient rule say to do with those exponents? Subtract, doesn't it? Doesn't it say that that will be x to the 2 minus 5? And what's 2 minus 5? Negative 3? All right, now we just looked at this new rule that says, oh, you can't leave it like that. What does that negative exponent say? Move me. It says take this base and move it across the implied fraction line. Okay, so it will move down to the bottom. The exponent will become positive. Well, what's left in the top? A 1. All right, now that's what it says. Let me see if I can convince you that that makes some sense, this step where I did the moving. Let's take this same expression, x to the second over x to the fifth. Let me scoot this up just a little bit. And I would like you just to think about what it means. Doesn't it mean x times x on the top and x times x times x times x times x on the bottom? And can I reduce that fraction? Yes. Common factor, and every time I divide out a common factor, what am I really leaving behind? Little ones that I get real lazy and I don't write. So what does that leave me with in the numerator? A 1. And in the denominator I have 3 factors of x. Did I get the same answer? Yes, I should be able to compare. And I did get the same answer. So maybe indeed it does make sense for a negative exponent to say, oh, I'm just in the wrong place. Move me. Okay, so we're going to remember that every time we have a negative exponent, it says move the base. I want to look at just a couple of other quick things before we start looking at the math lab questions. If you have x to the negative 2 over, say, y to the negative 5. Now, I can't use the quotient rule because those are not like bases. One of them's an x and one of them's a y, so I can't do that subtraction of exponents. And I look at this, what does a negative exponent say to do with that base? Move it. But this base had a negative exponent also. So it says, move me also. I haven't shown this until right now. A negative exponent will become a positive exponent if you will move its base across the fraction line, top to bottom or bottom to top. What does this become? y to the positive 5 over x to the positive 2. Now, I could prove that with some long work, but I'm not going to do it. I'm going to ask you to recognize, or just believe me, actually, that a base with a negative exponent that's in the top needs to go to the bottom. A base with a negative exponent that's in the bottom needs to go to the top. Okay? Sometimes, one last one, if you had, say, x to the third, y to the negative 8. Do you agree that that is an inappropriate form? All right. So, do both of these bases have negative exponents? No, only this base does. So only this base moves. This will become, well, I know that the y to the positive 8 is going to be in the bottom. Where does the x to the third go? It stays on top. There was no motivation to move it. It didn't move. Is that okay? All right, so now we're going to look at the My Math Lab lessons and hope that I have enough room to work on these.
So, like, even if they're beside each other like that, you would know to just move it down?
Yes.
But if that y was, like, say, in the front and the x was second, then...
Still, the one with the negative exponent moves.
Okay.
It is the base with the negative exponent that moves.
So the negative exponent is on the bottom?
Yes, but it will turn positive when it goes down there. Okay, I'm going to copy over the problem so those of you in the classroom can actually read these. The first one asks you to simplify 5 to the negative 4. Okay, what does negative exponent say? Move me. So you will take this, you will move it across an implied fraction line, and it will be 5 to the positive 4 down here. What's left in the numerator?
1.
A 1. Now, this doesn't say anything about leaving it in exponential notation, which means that My Math Lab expects you to multiply that out. 5 times 5 is 25, times 5 again is 125, times 5 again is 625. So in problem number 1, you will only get credit if you have it multiplied out. Okay? Now, if you were taking a test, and you've got a take-home test, if you happen to leave your answer in the form 1 over 5 to the 4th, I would probably give you full credit for it. But Math Lab won't. All right, let's look at problem number 2. It has negative 9x to the negative 2. In that expression, what is the base of the exponent negative 2?
X negative 2.
It is just the x. Only the x is being raised to the negative 2 power. What would I have had to include if I wanted negative 9x to be raised to the negative 2? I would need parentheses, but I didn't have them. Okay, so only this base was raised to this power, which means move me. So the denominator becomes x to the positive 2. Make sure you change it to positive. Where's the negative 9 going to be? Still on top. It did not move. And I can't do any more work with that, so I'm done. It's negative 9 over x to the second. Is that okay? Negative exponent says move me. Problem number 3. I have 3 to the negative 1 plus 5 to the negative 1. What does 3 to the negative 1 tell you to do? Move it. That becomes 1 over 3 to the positive 1, but do I write a positive 1? No, I just kind of dotted it there to remind you that it's there. Plus, what will this expression turn into?
1 over positive 5.
1 over 5 to the positive 1 power. Do we need those positive 1 powers? We can just ignore them. All right, can I add those two fractions together? Yes, What do you have to add two fractions together? A common denominator. So if you'd like, I'm going to do this problem. Let's see, I've got to have a little spot. I'll just work it right down here. I have 1/3 plus 1/5. What's the common denominator? 15. 3 goes into 15 5 times, and 5 times 1 is 5. 5 goes into 15 3 times, and 3 times 1 is 3. If you add those together, you get 8/15. So this was all that problem, and the final answer is 8/15. Yes?
How come, like on the other one, how you said the negative, you move it and it goes on the bottom, why this one didn't go on the bottom?
It actually did go on the bottom. This used to be 3 to the negative 1. Where did the 3 go? It went to the bottom of the fraction.
But I thought the negative was the one that gets.
Okay, look back up here. Let me go up. Look at this problem. What is it that moves? The base moves. The x goes to the bottom. The exponent changes its sign to positive. All right, if I look at this problem, the 3 goes to the bottom of the fraction. The exponent of -1 became +1. It's right there. I just dotted it. The 5 went to the bottom of the fraction. The -1 became a +1. When you move it to the bottom and it appears as if there's nothing left on the top, there's really a 1. And I actually even did the same thing on number 1. 5 to the -4. 5 needs to go to the bottom. The -4 became a +4. This one may have looked a little different because it was a 1 as the exponent. And then I had an addition problem to do, and I had to actually go off and do that. Okay? Let's look at number 4. The problem is 1 over p to the -8. The instructions ask me to simplify this and use only positive exponents. So here is a base with a negative exponent, and what does the negative exponent say? Move me. So it moves up. It gets multiplied by whatever's on top, but that's a 1, so you don't see a change. I get p to the +8. What's it over now? 1. Do I write that? No. So if you have a base with a negative exponent on top, it moves to the bottom. If you have a base with a negative exponent on bottom, it moves to the top. It always says move me. And number 5, I think, yes, the only thing that changes signs is the exponent when it moves positions. Exactly. All right, let's look at number 5. It has p to the -2 over q to the -3. This is not a case of the quotient rule because p and q are different bases. So what does this say? Move me. But what does the q to the -3 say? Move me also. So what does this become? Numerator, q to the +3 over, and there's nothing more I can do to simplify that. A negative exponent says move the base, change the exponent to positive. All right, now number 6. Number 6 is the first of a few problems that perhaps will use multiple rules. So I'm going to go down to the notebook part of this little page, and I'm going to remind you of our rules. Our rules, and by the way, I'm going to write them in the same order that they're on your blue sheet. Okay, the order that they're on your blue sheet is my suggested order of the way that you use the rules. The first rule is the power rule, which says if you have a to the x and you raise it to the y, you get a to the xy. The next rule is the product rule. The product rule says if you have a to the x times a to the y, product of like bases, you do what with the exponents? Add them, x plus y. The quotient rule is next, and it says if you have a to the x over a to the y, what do you do with the exponents? Subtract them, x minus y. And finally, the negative exponent rule says if you have a to the negative x, what does that become? Move me down, 1 over a to the positive x. So that's just a little reminder of the rules, but what I'm doing for the first time is encouraging you to use them in this order. Use them in this order. Now, this is not a rule of algebra. It is just a suggestion that this order will cause you less trouble in the future if you'll always use them in this order. Now, let me try to communicate to you by example. All right, problem number 6. It is y to the negative 5 over y. Now, I know that since we're studying negative exponents, this is standing out in your mind. But I'm going to ask you to be patient about it because the rules are in this order. Power rule. Is the power rule indicated in this expression? The power rule would have parentheses with a power on the outside. And I don't have that, so I'm not going to use the power rule. Next is the product rule. Do I have a product of like bases? No, so I'm not using the product rule. Quotient rule. Do I have a quotient of like bases? Yes. So I'm going to use the quotient rule. The quotient rule says keep the base y, take the top exponent, write down a subtraction sign, and write down the exponent of the denominator, which is 1. What is negative 5 minus 1? Not negative 4, but how about negative 6? A negative plus another negative, I add them up and keep it negative. Okay? So, y to the negative 6. Now, if I think about the rules, I did not need to use the power rule. I did not need to use the product rule. I just used the quotient rule. The last rule that I need to worry about is there a negative exponent left in the expression? Yes. And it says, move me. Your final answer is 1 over y to the 6th. Now, as soon as I finished the problem in my first class, someone said, I did it differently and got the same answer. I understand that. My person in my first class said the first thing I did was move it. Now, that's not my suggested order, but does it work? The answer is yes. So I'm going to say the word or. Could I look at y to the negative 5 over y? Now, this is not how I would suggest it, but it worked, and so I want to tell you that using this order, 1 through 4, is not mandatory. What she said was, I moved it first. Okay. What was left in the numerator? Okay, up in the top, what's left? A 1. So I have a y that's down there. I brought to it a y to the 5th. And when you move something, it gets multiplied by whatever is there. So now, she said, now I have the product rule. Yes, you do. Keep the 1, y times y to the 5th. If you add those exponents, what do you get? 6. Did we get the same answer? It's yes, we did. So was there anything wrong with the way she did the problem? Not at all. Having done this for decades, I'm not going to say centuries, but I am going to say decades, I know that if you use this order, then on the really complicated problems, things go better. That's my only reason for encouraging this, is that it will help you as the problems get more complicated. And I printed it in this order on the blue sheet for that reason. All right, Let's look at number 7. Problem number 7 says to simplify the expression, write the results using positive exponents only. This is going to help us make sure that we use the rules in the suggested order. Although nothing bad will happen to you if you go your own way. All right, power rule. That's first in the list. Do I need to use the power rule? Now the power rule is going to have parentheses with a power on the outside. I don't have that, okay? Next in the list, product rule. Do I have a product of like bases? Yes. So I will use it. X to the third times x to the fourth gives me x to the seventh, and it's still over x to the second. So I didn't need the power rule. I used the product rule. How about the quotient rule? Yes, I have the quotient of like bases. So what do I do with those exponents? Subtract them. 7 minus 2 is 5. The last rule is negative exponents. Are there any negative exponents? Problem done. Could you have done it differently? Probably so, and still gotten the right answer. I just encouraged this order. There weren't any negative exponents in that problem. Okay, let's look at number 8. Same instructions. I'm supposed to simplify and write with positive exponents. I have x to the fourth, y to the sixth, in parentheses to the negative ninth power. If I use the rules in my order, do I need to use the power rule? Yes. This exponent on the outside needs to affect both of those factors. And what does the power rule say to do with the exponents? Multiply them. So I'm going to get x to the negative 36th, y to the negative 54th. That was the power rule. Product rule. Are these like bases?
No.
No, so I don't get to use the product rule. Quotient rule. Well, I don't even have a written denominator, so no. Negative exponent rule. Yes. This factor needs to move, and this base needs to move. So my final answer will be, I will get x to the positive 36th, y to the positive 54th in the denominator. What do I write as my numerator? 1. Done.
So if they both negative, they go to the denominator?
Yes. If both factors as bases have negative exponents, then they both move down. Any base with negative exponent moves. Yes, sir.
I have a question. The exponents, they always have to end up on substitution?
Yes, sir.
Because,
They never stay negative. It is considered a forbidden form to leave it negative. You know how when you were much younger, your teachers would never let you leave a fraction improper? They would say, oh, that's bad, you need to change it. Well, right now, I'm being one of those teachers that's saying never leave an exponent negative. You might encounter a time in calculus where somebody might say, oh, it's okay. But it's not okay in here. Okay, well, if you don't go to calculus, then you're never going to get that message. So my message is, don't leave a negative exponent in an answer. I have to count it wrong. All right, problem number 9 says to simplify this expression, I have negative 6 m to the 6th over negative 3 m to the 5th. Okay, power rule. Do I need to use the power rule? No. Do I need to use the product rule?
No.
Do I need to use the quotient rule? Yes, the quotient rule is appropriate. Now, be kind of careful. You've gotten so focused on working with exponents that sometimes people forget what to do with regular old numbers. What is negative 6 divided by negative 3? It is 2. Every once in a while somebody will say, oh, I thought when we divided we subtracted. When we divide like bases, we subtract their exponents. We have not quit doing traditional division. Okay, so that's a 2. Now, This is a quotient of like bases with exponents. What does the quotient rule say to do? Subtract. What's 6 minus 5? 1. Do I need to write the 1? No. Now, there is a little invisible 1 right there, but you would not write it.
If we write it, are you gonna count it wrong?
I'm not going to count it wrong, but MathLab might get mad,
Okay.
okay?
So why did we all of a sudden divide those?
Because those are traditional numerical coefficients. They're plain old numbers. So,
We don't use them before? Or is it just like X and Y?
right. We haven't had any of those for a while. All right, let's look at problem number 10. All right, number 10, if I rewrite the problem, it has parentheses, x to the negative 2, y to the positive 2, over x to the 4th, y to the 4th. It's enclosed in parentheses with a 3 on the outside. Is that a case of the power rule? Yes. This exponent on the outside will affect each and every one of the exponents on the inside. The the power rule says multiply the exponents. So I will get x to the negative 2 times 3 is negative 6. Y to the 2 times 3 is positive 6. Over x to the 4 times 3 is 12. Y to the 4 times 3 is 12. We just use the power rule. Now, do I have a product of like bases? No, I have a product, but it's not like bases. Do I have a quotient of like bases?
Yeah.
Yes. So the quotient rule says keep the base, write the top exponent minus the bottom exponent. So for the x's, it was x to the negative 6 minus 12, y to the 6 minus 12. Always the top exponent minus the bottom exponent. So what does that give me? X to the negative 18, y to the negative 6. So with the x's, they were both negatives. So I added and kept it negative. For the second one, it was a positive and a negative. I subtracted and kept the sign of the larger. Am I done?
No.
No, because I can't leave those negative exponents. Both factors have negative exponents. They both get to move. I end up with 1 over x to the 18th, y to the 6th.
You lost me.
Okay?
Where it's up, when you got negative 6.
Oh, I see.
All right. I have 6 minus 12. So I subtracted and kept the sign of the big one, which was the 12. Using the addition rules, although I didn't write it, remember there's kind of an implied little plus there. So it's really 6 plus, oh, that's a mess.
So you're subtracting the x's, right?
I'm subtracting the exponents of the x's and subtracting the exponents of the y's. 6, if you look up here for a second, it's negative 6 minus 12, that's what I wrote right here. Then it is 6 minus 12, and that's what I wrote right there. And I have a little blob here which will be difficult to erase. So negative 6 minus 12 is negative 18. Positive 6 minus 12 is negative 6.
See how, can you go up some?
Uh-huh. More? And I ended up with negative exponents, and I had to move those factors. So I had to use multiple rules in this. And what you have to be careful about is usually the quotient rule when you have to do the subtraction. Let's look at 11. This is the last one that uses multiple rules. And I'll write the problem bigger. I have parentheses, x, y to the third, raised to the third, over x, y to the negative 2. Okay, the rules. What's the first rule you check to see if you can use? Power, and I can use it. So when I use the power rule, I'm going to have this 3 affects both of the exponents here. So what am I going to get? X to the third, y to the 9th, multiplying those exponents, over on the denominator, x to the negative 2, y to the negative 2. Whoops. Is that much okay? That was the power rule. Now I want you to be really careful and perhaps just look up and don't write yet. I don't have to use the product rule, but I do have to use the quotient rule because I have like bases on top and bottom. So when I do the x, what does the quotient rule say to do? Subtract. Subtract. Write down the top exponent. So I'm going to write down a 3. I'm going to write down a subtraction sign because that's what the quotient rule says to do. Then I'm going to write down the exponent from the bottom, which is a minus 2. So it is 3 minus a negative 2. It is 3 minus, because it's quotient rule, negative 2. Y to the, what will I write down? 9 minus, because it's quotient rule, negative 2, because it was the bottom exponent was a negative. What I see people do as a mistake is put 3 minus 2. That doesn't show that you wrote down subtraction. It's 3 minus negative 2. It's 9 minus negative 2. So now I'm going to change that minus minus into plus, and I end up with, yes, I get x to the 5th, y to the 11th. I would imagine if anything bothers you about this problem, it is not the algebra. It is the positive and negative numbers. That's what tends to get people. So remember, when you use the quotient rule, if I repeat it, says if you have a to the x over a to the y, you get a to the x top minus y. But in my problem, I have x to the third over x to the negative 2. It's 3 subtract negative 2. Minus minus means plus. 9 minus, because it's quotient rule, negative 2 minus minus means plus.
So how do you know when to use the product rule?
You would use the product rule if the problem had an x, say, to the third and an x to the 9th, where they are both x's.
Oh, same at the bottom.
Yes, saying all that, and you can't even see it. That would be a case of the product rule, where the x's are beside each other on the top or on the bottom. Okay, so that would be product rule, product rule. Whereas this one is quotient rule, quotient rule. Okay, and in this case you add the exponents, and in this case you do a subtraction problem. Okay, good question. I'm glad we brought that up. All right, it might be helpful for you to have your notes out while you're actually doing the My Math Lab, because your number 11 in Math Lab is going to be similar to this in structure. All right, the second objective for section 5.5 is scientific notation. This is a pretty straightforward concept. It does use negative exponents, and I'm going to show them the way that the author of your book does. I think it's pretty clear. All right, scientific notation. There is something called standard notation. Standard notation is just the way you write numbers. Maybe we have a really big number, 5,200. We'll just say it's 5,200. That would be the number in standard notation. Scientific notation has the following characteristics, and I know you've been exposed to this sometime somewhere. You might have the same digits, but the decimal point will have to be between, and I'm going to do the decimal point in blue, it will be right after the first digit. Okay? The decimal point always comes after the first digit. Well, if this is 5.200, you wouldn't have even written those 0 zeros. So this is the same as 5.2. Now, if you're looking at this, you're saying, I'm sorry, but 5,200 is not the same as 5.2. They're not the same. They can be equal if I multiply this by the appropriate power of 10. The appropriate power of 10. Now, how do you know what the power of 10 should be? I'm going to teach this in a lot of detail. Where's the decimal in standard? Isn't it here at the end of the number? Well, where did it move? It used to be here, but it moved 1, 2, 3 places. However many places it moved, that's what you use as the exponent. 10 to the third. And that is just a dot that's left there. Yeah. Now, maybe just put it on silent. All right. I just wanted to do one problem to start with. I'm going to teach you how do you know where to move the decimal, how do I know what kind of exponent to put. I wanted you to just look. This is a standard notation number. This is a scientific notation number. One other thing I want to show you before we look at problems. What if I have a standard number, 0.0064? That number is a tiny little decimal number. When it goes into scientific notation, the decimal point still needs to go after the first non-zero digit. So it still needs to change to a 6.4. In scientific notation, it is always one number that's not 0 to the left of the decimal point and then whatever's left over. All right, now, those aren't the same. So, times 10 to what power? Well, how many places did you have to move the decimal to get it here? You'd have to move it 1, 2, 3. But this won't be a positive 3. This will be a negative 3. How will you know when it should be positive and negative? Some people teach about, oh, if you move it this direction, it's this, and if you move it this direction, it's something different. And I don't teach it that way because I think that can get confusing. Here's what I'm going to tell you. In standard notation, if the number is big, then the exponent is positive. If the number is a tiny decimal, then the exponent is negative. And I'm going to write that down. I'm going to write down big number, positive exponent. Tiny decimal, negative exponent. And that's all you have to remember. Big number, positive exponent, tiny number, negative exponent. Let's look at several problems. And I won't worry about left or right because it will make sense to you, I believe. Problem number 12 starts out as 34,000. I'm not going to write the comma because I don't want it to be confused with a decimal point. That is a standard notation number. I want to change it to scientific notation. Okay. Just in the decimal part, what will it start out being? Excellent. It will be 3.4. Will I need to write down the rest of those zeros? No. All right, so it's 3.4. It's going to be times. Now, when you answer these questions in my math lab, there will be a times sign, an X, which we've sort of abandoned because it looks like letter X. It will look a little different. It will be over in the tool palette. Okay, so it's 3.4 times, and I know it will be 10, and now I have to figure out the power. So I'm going to write it, I'm going to show the decimal change in red. It starts here. I have to move it 1, 2, 3. Do you agree I had to move it 4 places? Now, will this exponent be a positive 4 or a negative 4?
Positive.
And why? Because it's a big old number. So I don't want to think about, oh, I went to the left or I went to the right. Don't worry about that. Big number, positive exponent.
So to figure out like what the power is, you always start from 0?
You start from where the original position of the decimal should be. And in a whole number, it's always on the right. Okay? All right, now let's look at number 13. Starts out as 1,260,000. One more 0. And I want to change it to scientific notation. What will just the number part of this be? 1.26. And it will be times 10. All right. So now, even if you can do it a whole lot faster, I'm going to take a moment, switch color. The original decimal point is on the right-hand side, and I would need to move it 1, 2, 3, 4, 5, 6 places. Will it be a positive 6 or negative 6? Positive, because it was a big old number. Let's look at number 14. I have 0. Let me count those. 1, 2, 3, 4, 5 zeros and a 198. That's a standard notation number. In scientific notation, what will the number part of it be? 1.98. It'll be times 10. And I need to count. It started out over here, and I need to go 1, 2, 3, 4, 5, 6 places. But it will be negative 6. Why? Because it's a tiny decimal. Is that okay? All right, now we're going to practice a few problems where the problem starts out in scientific notation, and we're supposed to go back to standard. I start with 3.378 and times 10 to the negative 6. That's how I start. How many places will I have to move the decimal point to get it back to standard? 6. Now, why did you say left? You're correct, but why left? Because it's negative. Says this is supposed to be a tiny little decimal number, and I would need to move its decimal point 6 places left because I'm trying to make it a tiny decimal. So it will go 1, whoops, I meant to go in color. It will go 1, 2, 3, 4, 5, 6, and I have destroyed the question, but I will fill in with 1, 2, 3, 4, 5 zeros. So my answer in standard form is decimal point 1, 2, 3, 4, 5, 3, 3, 7, 8. There is a possibility, I think this will be fine, there is a possibility that my math lab would want a 0 in front of the decimal point. I am not positive about that.
Is that 15?
Yes, yes it is. That is problem 15. So I didn't worry about which direction until I looked at this problem and said, oh, negative exponent, this has got to turn into a tiny decimal. The only way that's going to happen is for the decimal point to have moved to the left.
So if it was positive, you would have gone to the right.
All right, and that'll show up in number 16. 16 starts out as 1.841 times 10 to the 9th power. and I need to change that to standard notation. Is that going to turn into a little bitty decimal or a big old number?
Big number.
Big number, which means I need to move it 9 places to the right. So I'm going to write it down here. I need to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, and drop it, which means I need to fill in with 1, 2, 3, 4, 5, 6 more zeros. My answer is 1841 0, 0, 0, 0, 0, 0. I will put the commas in that. And I think that's 1,841,000,000. And if they get a whole lot bigger than that, I can't even say the names of them. All right, let's look at the last one. Well, I don't actually even think we have to do the last one because it's just like this except 8 decimal places. So are y'all okay with scientific notation? All right. Then we will say that lesson 5.5 is finished. Negative exponent says move me, and then we dealt with scientific notation.